What I'm going to do is that I'm just going to introduce the what we are going to talk about. So we have took some feedback from the last few Cloud Field days, and this time instead of going through like a lot of slides and PowerPoints, we want to keep it real, right? I mean, let's take through a journey of a customer, and this is a recent customer example. We have worked with a very large enterprise. What sort of challenges that they ran through? In kind of, they have done some work, they started with their own kind of DIY journey, hit some snags, and they want to kind of go back and build everything ground up the right way. So let's walk through the journey of a typical customer example, and that's applicable to pretty much all the large enterprises in a similar board who wants to have many VPCs, VNets, applications, services, serverless functions, and they want to connect everything together. And while ensuring like 3 to 4 core principles, security, of course, topmost. How do they segment the traffic within the cloud, across the cloud? Cloud to data center. We cannot forget data center. It's still the integral part of any cloud deployment. They have certain workloads is still running. How do you provide that secure connectivity? How do you ensure that you are optimizing the traffic while you're connecting? So performance SLAs, kind of low latency fabric. How do you can utilize better path based on the optimized fabric there? And then like foremost, the thing is how you can observe, right? I mean, what is happening? How the traffic is being connected, how the users are connecting, how my apps are connecting. So how do we provide that in the lens of our customers? So I'll kind of give it to Gaurav to walk you through that, a real life customer example with the architecture, what are their challenges when they started talking to us, how we kind of moved them to the next stage. Over to you, Gaurav.
Sure. Thank you, Faraz. Again, good afternoon, everyone. My name is Gaurav, and I'm a Principal Solutions Architect here at Prosimo. So as Faraz shared, in this session, I'm going to walk you through a customer case study. I'll walk you through the challenges at a high-level architecture that we actually devised for the customer. And then we'll go into the demo and see how Prosimo solved these specific use cases / challenges for that customer, right? So this customer is a global healthcare services company that we started engaging with roughly 6 months ago. And their journey has been like a typical enterprise, right? 6-7 years ago, they started migrating to the cloud. And at that point in time, their focus was, hey, let me make sure that we migrate these applications to the cloud and actually they are working. And in their own language, networking has always been an afterthought, right? We just wanted everything to be up and ready. And now that the migration was done, applications are running, we started growing in the cloud, and now we are at a point where I have hundreds of AWS accounts, hundreds of Azure subscriptions. We are soon acquiring companies that are in GCP as well. I still have my 2 data centers running. And I'm running into these typical challenges. Hey, developers have access to everything. They are creating these virtual networks where they can launch these AKS clusters, EKS clusters. And now this developer needs connectivity to some service. So they'll go use any cloud native networking construct, VNet peering, VPC peering, transit gateway. They're updating route tables. And we are finding ourselves in a situation where I really don't know how to make sense of it. I am not able to enforce an architecture that brings in security into the mix. I'm not even sure if my network architecture is scalable, it's redundant. And at the end of the day, we are acquiring all of these new companies. So how do I even make these services talk to each other? So that's where the discussion started. And the first point was they help us make sense out of it, help us rationalize this network architecture, help us standardize this network architecture. Now, the other thing was that, my services and applications are no longer sitting inside a virtual network boundary. As Mani mentioned, they started using PaaS services. For example, Azure PostgreSQL database. That is a managed service that doesn't sit in any virtual network, that's managed by Azure. If I have to enforce the same security standards where how the communication should work, how do I bring these kind of services into mix? The other challenge was that when we started actually using these services, at that point in time, there was no private connectivity. So these endpoints were available through internet. And what I'm actually doing is my developers are actually going and they can pretty much access it on the internet, right? And since then, cloud providers brought constructs like private link, for example. So now we want to integrate those constructs so that all of my traffic at any given point in time is always private. So can you help us with that? Another interesting thing is because this company is a healthcare services, they talk to a lot of or they have to talk to a lot of business partners in the healthcare industry. So I am publishing a service, an API or an application that my partners need to access. Right now, I want to give them private access. How do I actually make it scalable? How do I make it secure? And in the end, what happens is that because there is this jumble of network architecture that we have made, VPC peerings, VNet peerings everywhere, at the end of the day, my network operations team has to go and manage it. If at all something goes wrong, I don't even know where to begin troubleshooting because the connections are everywhere, right? So can you give us these tools or some visibility into how my traffic is flowing from source to destination? And as Faraz mentioned, I think the last thing that they really wanted, of course, they were talking about, what developers are creating these peerings and connections, and we don't even know they are updating these route tables on their own. At the end of the day, all of us are serving for those developers to be successful. So wouldn't it be awesome that if I had a tool where if a developer belongs to, let's say, a business unit 1, and he goes to that tool and says, I'm developing this application, and this application needs access to these 5 services. I need access to a DNS server, maybe in some auth service, somewhere where I can send my logs to, some Grafana instance, for example. And based on his role, somebody has already published these 5 services on that portal. We call it developer self-service portal, right? So now the developer just has to go and click, I want to access this service 1, 2, 3. And under the hood, all the networking is already taken care of. They don't have to worry about how do I stitch my application to this service? How do I stitch my network to this service? So that's the whole concept. That's what they want to do. So these are some of the objectives that they wanted to achieve. I'll walk you through the architecture that we propose to them at a very high level. And once I've gone through it, I'll walk you through actually the demo. But before I get into it, any questions?
One thing when we describe developer velocity and developer productivity, it's always such an odd thing. Do you see that as the developers not wanting to set up networking, developers not wanting to continue to operate networking, making secure networking native to development? I'm just trying to think of like how to very specifically describe how do we make a developer's experience better in like tactical terms.
Right. So in my mind, the way we think about it is that developers are more than happy to make things work, right? I have need to access this service today, and I have access to the tools. I can go and pretty much do anything in the cloud. So I'm just gonna do it. I'm gonna update the route tables. And just build the connectivity and I'm done, right? The problem that happens is what after that? Was this service was your application in the first place supposed to talk to this service is a bigger question. And then now you've built this connectivity. We're not even sure that, hey, how is it following the best practices when it comes to cloud governance, when it comes to security? I wanted all of this traffic that is heading to this service to flow through a pair of firewalls, but that's not happening. I think it is a bigger problem from network operations point of view. But at the same time, we don't want to take that away from developers. We really want them to still operate at that speed, but without having to worry about how to set the underlying network.
So what we have also seen in our experience working with customers is that they are the consumers of this kind of a platform, right? They want to consume the network resources. They do not want to essentially set things up themselves because it's a cloud center of excellence team, cloud infra team, networking team. They do not want to have, even sometimes they do not even have access to create a TGW attachment, for example, right? So they want to build this kind of consume this model which is built by these CCOA teams like giant networking highways or application highways, where they can simply consume the services. So you expose a network or an application to me, like a DNS service or Active Directory. I'll just simply attach my application to it. And then second part is the guardrails itself, right? How do you make sure that you are not attaching your services randomly, right? It has to have certain governance rules with the proper rollback permissions and whatnot. So those are two primary areas that we have seen in our customer engagements.
Great.
Without adding, to great summary, right?
Yeah.
So the way I look at it, right, when an application developer is developing something, he's requesting, 12 gigabits of memory. Doesn't care where that 12 gigabits is coming from, right? I need these many vCPUs. I don't care where they're coming from. I don't need to be provisioning this stuff, right? It should be very similar with networking. And the challenge is that CPU, memory are sort of system constrained, right? Unfortunately, when you make a change in networking, it can have widespread effects. So they really don't want to touch it, right? But they want the flexibility. They want the semantics that allow them to be able to configure these things fast, right? Hey, I want connectivity to these services. And I don't care where they sit. I mean, if you need to set up transitive routing across this multi-cloud framework to get my application access to this database, just make that happen. I'm requesting this service. And they want that velocity. They'd rather deal with the business logic rather than take on the responsibility of setting up all of this plumbing. And then on top of that, you layer constructs like, is it, am I doing things in a secure manner, right? It's really not stuff that they want to be worried about. These should just be standard off-the-shelf sort of constructs that are available for me to consume, just like, CPU and memory.
Right. Great, and thank you for that, because it's one of those questions where we come up with these bold marketing-sounding answers of velocity and time to market, but great context. So thank you very much.
Thank you. Of course, thank you. So from here onwards, what I'll move into is the high-level architecture diagram and how we designed it, and then I'll walk you also through the exact demo. So the very first thing that you have to do as a customer if you want to solve this challenge and using Prosimo as a platform is build something called as this Prosimo fabric layer, right? Think about this fabric layer that you actually build in your cloud accounts using Prosimo data path components called Prosimo Edge. Now, these are, you deploy these in your own cloud accounts, in your own data center, and this fabric spans across regions, spans across clouds. Even though I'm showing it linearly here, it's a full mesh of these edges, right? So you go ahead, deploy these edges from the control plane, and once the edges come up, they are capable of discovering each other. They'll build a full mesh among them, and in the end, what you will have is this fabric that you can attach multiple things to. Now, before I go into what can you attach to this, the question is, hey, what does this fabric build of, right? So the main component of this fabric is something called as Prosimo Edge. Now, its Prosimo Edge has a containerized form factor. We deploy it using Kubernetes and using native Kubernetes service by a given cloud provider. So let's say you're deploying Edge in Azure, we will use AKS there. If you go and deploy Prosimo Edge in AWS, it will use EKS, and the same thing goes for GCP and GKE, right? The advantage that it gives us, because we use Kubernetes for this construct that is the brain of the solution, the high availability is built in, redundancy is built in. It can scale out and scale in. Let's say behind this edge, you are attaching hundreds of networks or hundreds of applications. They are sending hundreds of gigs of traffic. As long as the underlay can support it, Prosimo will scale out. And once the traffic is gone, it can scale back in. Now, that is the advantage because we are not asking our customers to go and deploy these VM-based form factors in every VPC. You don't have to make any change to your existing network, existing VPCs, your existing applications. It's sitting in your own cloud account. So, and it's a very seamless process to deploy it. You go through the control plane, choose what region you want to deploy it in, and we take care of everything that is required for this edge to be functional. So that is there. Now, once we have deployed this backbone or Prosimo fabric, the first thing that comes to my mind is, okay, you know what? I want to be able to, what do I do with it, right? What I'm doing is I'm actually going to attach my networks to it. That's more at the layer 3 net. Now, I can have my networks in the data center. I can also have my networks in AWS, single region, multi-region, in GCP, in Azure. And what you do is you attach these networks to this Prosimo fabric. Now, you will see a lot of colored lines here. Let me just explain that. What these colored lines means is the concept of segmentation. Like, essentially, if you see here, hey, I have my production environment, I have my development environment. I also have my network segregated or application segregated as business units. How do I actually, if I'm attaching all of them to the same fabric, how do I build that segmentation? So through the construct called as namespace, whether Prosimo brings to the table, you can actually create this segmentation, and that is global in nature. So if you have a prod network segment, you can attach your network from data center to it. You can attach your network from AWS, from Azure, from GCP. So this network is global in nature, and it spans across the fabric that you've built.
Sorry, and the namespaces, that's your term. That doesn't have anything to do with the Kubernetes
that's
namespaces.
Right.
That's your
term.
Okay.
Yes. So that's what we are doing, right? Now, so we attach networks, amazing. It's now probably my AWS network is also attached to the same fabric. My GCP network is also attached to the same fabric. What else can I do with this fabric? You can actually go ahead and bring in your services as well. So it's not just about just attaching these networks. As we shared earlier, I'm using this Azure PostgreSQL managed service from Azure. And can I actually attach that service to the fabric itself? So that, because it doesn't sit inside any network boundary as such. So you can bring in your services, your applications. Your services can be microservices that are running inside Kubernetes cluster. Let's say you are exposing them out of the cluster through some means. Your services could be PaaS services. Your services could be also running on a serverless architecture. And I'll show you how you can bring them and make them part of this Prosimo fabric. So you can attach these services. Now, should they be able to talk, right? Let's say they are actually attached to the same fabric. Should my networks, even though they are segmented, should they be able to talk? And what we follow is trust nothing philosophy, where you have to actually use a policy construct that will define who can talk to who, right? So you have attached networks and services to this common fabric. Everything is routable, but they cannot talk by default unless you specify, unless your network engineering team or your cloud operations team shows the intent that we want this network to access this service. We want this service to talk to this other service. So, and then you can, of course, route it through the firewall, through service insertion, and all of that comes into picture. But at a high level, this is what I wanted to show you, that, hey, you build this fabric that spans across regions, you're bringing in segmentation, you are attaching these services, you're attaching these networks, and the way you are controlling what talks to what is through the policy engine.
So within the fabric, so we have a node in GCP, another one in Azure. How do they communicate with each other?
Yeah. So what happens is, so you have a node in GCP and you have something else in Azure. The process, the way they work is, you have to attach those networks or those nodes to this Prosimo fabric. And I'll walk you through the process of how you do it. Let's say in GCP, your application is sitting inside a VPC, for example. So you use we will onboard that VPC onto Prosimo fabric. We can use any cloud native networking construct. For example, let's say VPC peering, or you want to use private service connect in GCP. The same thing goes for Azure. So customers have all the flexibility that they need on how they want to attach these things to Prosimo fabric. We support all the cloud native networking services that are out there, right from private link to VPC peering to VNet peering to transit gateway to virtual WAN hubs. And for some reason, if customer doesn't want to use any of them and they want to use actually a public internet, you absolutely can do that as well. But the idea is that with this architecture, and especially in this customer's context, right? It's a brownfield environment at the end of the day. They have made it work somehow. They are using these cloud networking constructs. We don't want our customers to go rip and replace everything that they have built and then just replace it with what Prosimo is trying to do. What we are saying is that as long as you build this fabric in your own environment, you can use anything that you're using that is existing in your network, and we will consume it, will ingest it, and that is how we will route this traffic from GCP to Azure.
Let me try a different angle. So Prosimo will be deployed, let's say, in GCP and in Azure. So essentially, it is what an actual node, some sort of a virtual appliance. Of does it communicate with another one in a different cloud provider?
That is right. Just one slight correction there. This is a Kubernetes cluster. I mean, think about this Prosimo Edge as a cluster that is running in a customer's environment. So these two can talk to each other. Just taking a specific example, in your case, they will build secure tunnels over internet to between these two edges, and that's how your nodes from here can talk to the nodes in Azure. But a lot of times customers want to even build this connection over a private circuit. Let's say, hey, I already have Equinix connected through Azure Express Route and GCP Interconnect. Can your edge clusters talk over that private circuit? And you absolutely can do that.
Okay.
So I'm a little lost, just a little bit, because when I hear the term fabric, I think IP versus something like a service mesh, where I'm calling service, where I have a directory of services, and I'm accessing, I'm doing communication from one service to another one over this secure encrypted service mesh. Help me differentiate how you're using the term fabric versus a service mesh. Is this a overlay network, a fabric? This is a fabric in the sense that's just like an EVPN or some type of overlay. I have a set of services, and it gets complicated as we're talking about the abstraction of cloud. So I have a bunch of virtual IP addresses associated with services. That's more or less invisible to the developer or the consumer that's consuming the fabric. Now I'm using the fabric IPs and service names to add to access that, for lack of a better term, underlay of services.
Great question. So absolutely yes. So the way, and I'll answer this in two parts. One, when we say fabric, what I essentially mean is that you are building this highway where you can send network traffic to it just at layer 3, but you can also send layer 7 traffic over it, right? Like these edges are capable of understanding all the way from layer 3 to layer 7. So now coming back to your specific question around service mesh, hey, if at all, let's say there is a service that is running in Azure and I have a source that is sitting in GCP or in AWS, they want to consume that service. As you rightly said, hey, that service, I may not even know the actual IP of that service, or that service is sitting in an auto-scaling group where it resolves to one IP today, but tomorrow it can resolve to 10 IPs. Yes, so when we onboard that service to our fabric, or when you attach that service to the fabric, the source doesn't have to know about what the actual IP is. When we assign it a virtual IP or a service IP inside our fabric. So from source's point of view, they're still accessing their FQDN cfd.app.com. It comes to this edge or Prosimo fabric. It knows, okay, I know the actual IP wherever it exists, it's in Azure. So I'm going to send it to my Azure edge. And then this guy goes and it knows what's the actual IP at that given point in time. And that's how we are routing it to the actual service.
So I attach my RDS to this fabric. And when I go to call, when I'm creating an application that accesses RDS through this fabric, there's some type of name resolution and some type of naming service running in this fabric that resolves to the actual AWS service on the underlay. But just as long as I'm using the fabric for communication, is secure, routable, et cetera, et cetera.
Absolutely. Just one point there, the exact use case we work with on a customer, right? RDS very specifically, today I have 2 read replica nodes. Tomorrow I may have 10 read replicas, right? One way to do it is, hey, I just build this VPC peering and I'm all good. But my RDS FQDN at this point in time is just pointing to this one reader node that I have read replica. But now I have scaled out, I have 5 read replicas. So the fabric should be intelligent enough that at a time when a customer is trying to access that, it should actually resolve it to the 5 endpoints, and then it can just hand it over to AWS, and then they can load balance it to wherever they want to send traffic to.
So this, just to kind of add to this additional context, right? So we loosely use the term fabric. It's like a collection of these edges, and these edges are the regional constructs Wherever you have workloads, applications, network services, you add an edge there. Now, the challenge comes is that how do you attract this? So some people are looking at this fabric as a pure IP fabric. They just want network-to-network connectivity. They don't care what are the higher layer or kind of deeper protocols that are running on the upper layer stacks. They just want to make sure that my 10.1.1 can connect to a 20.1.1, right? So at that point, the edges or this collection of these, or a mesh, if you will, of these edges works at pure IP layer, routing layer, nothing else. But then the scenarios that you explain about AWS RDS or a Redshift or maybe a service running inside a Kubernetes cluster, how do you bring that traffic to the fabric? So for that, we use all the underlay capability. So it's an overlay which uses a cloud native underlay, which means it uses DNS service from AWS or an Azure to resolve. Let's say the RDS is running on rds.cft.com. Just take an example here. How do I resolve this using a DNS service? So at that upper layer protocols, it functions as a proxy. So it has a deeper understanding. It can understand the SNI, it can understand the host header, it can see how to route the traffic. You can set up policies and path-based authorization that /index.html is allowed, but /contact.html is not allowed. Those kind of policies. I'm just kind of taking an example here. So in a broader sense, it kind of looks at all the protocols from layer 3 all the way up to layer 7, and you can define which endpoint you are actually attaching to this.
So in theory, I should be able to create rules within my fabric that have mismatch. So my policy is that this type of compute cannot run against my Oracle database. In traditional networking, I say IP address A can't or cannot access IP address B. Where that gets blown up in cloud is that if the compute is a Lambda or OpenFAS or something that isn't IP or pinned to an IP, that logic doesn't work. So in theory, I should be able to take these edge devices to say these Lambdas with this namespace can or cannot access this traditional Oracle database.
Absolutely. And we're going to go in detail and show you actually things in action as well in a bit. Absolutely on that use case.
For the Kubernetes, where do you see yourself pairing alongside of another CNI? Do you have an opportunity to replace the CNI? Because in a hybrid environment where the Kubernetes plus hybrid cloud, they are probably trying something right now. They've probably tried Istio. Sorry, folks. And it's probably a tire fire. Or they've tried another popular open source networking product. And again, super cool in that it solves a Kubernetes problem, but not necessarily translating over to traditional cloud, traditional on-prem networking. So I'm just curious, how much do you see yourself as getting rid of the need for another CNI for cross-cloud Kubernetes, or do you rather just partner and integrate with it?
So currently, let me answer it in two ways, right? So we do not sit inside the cluster. So we are not really a CNI.
Right.
So we want to bring the traffic as long as we have a reachability inside the cluster, whether it's through a cluster IP or some sort of like load balancer IP where you're exposing an app in the form of a DNS, or we integrate with some of these like console or service mesh type of tools. So we do have integrations today. We do not have near-term plans to kind of sit inside the cluster and replace a CNI, if you will.
Right. Okay.
But more with the partnerships with some of these integrations there.
Because a lot of them have come and they've started to try and unseat the load balancer folks because they're saying like, hey, we're already doing networking, let's just do load balancing. Yeah. But then they're also really struggling with MTLS generally in those spots. And that's why you guys have that MTLS, you've got the security story so strongly, but I also know it's a big lift when you get into running and being the CNI.
I have one question just to clarify it also while we are on the topic of Kubernetes. From what I understand, this setup does not necessarily, it can be for other services that may be running outside of Kubernetes, both on premises and in public cloud. And what you mentioned is that your fabric is running inside of Kubernetes on, for instance, respective public cloud providers. It becomes quite a crucial component in the whole setup kind of becomes a really important component to be up and running. And there may be customers that do not necessarily use Kubernetes. Let's say if we talk about Azure, there may be customers that are not necessarily using AKS. And as we know, managed Kubernetes service also does require quite a lot of knowledge and understanding of how to keep it up and running and upgraded and yada, yada, yada. So do you have is there any support in here in your solution? I assume that that you do not manage it once it's up and running on the customer side. So do you have some kind of help or some kind of way to
Understood. I think understood your question.
keep it stable? Yeah.
Yeah, understood your question and love your headphones, by the way. Amazing. So we do the life cycle management of these clusters. So it's not a customer responsibility, if you will, to manage the clusters themselves. We provide them full control using a SaaS dashboard. So when we spin up these Kubernetes cluster, we do not expect customers to be like 100% tech savvy with the Kubernetes platform itself. We take care of most of that. So we kind of handle provisioning clusters, kind of carrying the whole life cycle, patching, upgrades, those kind of things. So we do not put the onus back to customers to upgrade these things or spin up these clusters themselves. So throughout the life cycle of this, like when you spin up a data path, when you connect to resources, the dashboard itself has constant connectivity, which keeps on monitoring the health checks of it, any type of config updates, config pushes, upgrades, any type of vulnerability patches. Those are all being taken care of by the SaaS control plane.
Yeah. Okay.
So, Krishna, I just want to add that the workloads that you're connecting need not be just Kubernetes, right? We have mixed workloads like PaaS services, VM-based workloads, Kubernetes clusters, service mesh, anything you could attach. The data plane itself is Kubernetes-based, like Faraz and Gaurav mentioned, but what you attach could be any type of workloads.
Yeah.
So I have a question that I think is just kind of bubbling up from all of this excitement that is in the room, which is, say someone sees something like this and can go immediately, I have this problem, I need something like this. Are you currently in the 3 major cloud marketplaces in order to use them?
Yes.
Yes. Yeah.
Nice.
So you had a question.
Yeah, Christina kind of asked one of the things I was going to get towards, which was around the management of those Kubernetes clusters. And it sounds like, so the deployment and management is with you guys,
Yes.
right? Okay, cool.
It runs in customer's cloud,
Yep.
where we take the permissions to run certain things,
Yep.
but the lifecycle management is across
Like a managed PaaS offering.
Yep,
right?
so the
When you-
customers wouldn't be running anything else on that cluster that
Yes,
you've
that's
deployed,
right.
just specifically for your edge.
Yes.
It's like spinning up a transit gateway from AWS. The
Yep.
gateway comes up, but you're not responsible to ensure that transit gateway is up and running.
Yep.
Right? It comes with 4, 5 nines of availability. It's the same model for this one.
Got it, yep. And I heard about the scalability of that before. Being in Kubernetes, it's kind of managed that way. Sorry if I missed it. What's my decision around how many edges I would deploy? Do I just need like one in each of my cloud environments, or are there times where I would go more than one edge?
So you need one edge per region per cloud.
Per region, per cloud. Okay,
Yes.
cool.
It's a regional construct, but you just need one edge in that region.
Got it.
And then you can have hundreds of VPCs or VNets behind it, or hundreds of applications behind it.
Yeah. Okay, cool. And my last one, sorry, Keith.
No.
And tell me if you're going to get to this, but towards the end there, you showed some of those PaaS services and then attaching
Yes.
those into. Is that coming?
Yes.
Yes,
Okay.
it is.
Yes.
So I don't know if you're going to get into it or not, but I'm thinking transitioning from brownfield to kind of best practice. I'm assuming the services the underlying services, I'm a networking guy, so I'm going to call it the underlay.
Right.
Both underlay, the access control is dedicated to only talk to the edge devices. So as I want to lock down the network, as I go from brownfield to kind of best practice, I should be able to tighten those controls. Is there a mechanism that you folks have to automate that process?
Yep. It is automatically taken care of. You're right. So when a customer is attaching a network to our fabric through a process of onboarding, we make sure that in those VPCs and VNets, we update those NACLs or security groups to make sure that traffic is indeed flowing And we also update route tables. So traffic should start flowing through Prosimo, and then we process it, apply policy, do all the good stuff, and then send it to the destination. So customers at any given point in time, they don't have to touch anything manually.
If somebody is trying to go direct, Keith, they won't be able to, because now their policy says you have to route through this fabric.
As part of the onboarding, you're changing my cloud ACLs to
And routing.
And
right?
routing.
It's all
to
point.
make sure that it all goes through the edge.
That is correct.
Well, you guys use the example of a global healthcare customer that just started putting stuff in multiple clouds wherever they wanted. What if, in Keith's example, that's brownfield, and they decide, all these applications should have been in this one specific cloud, in this one region. We already have the fabric up; it's already applying to our workloads, but we're moving them. Does it travel with it? Is it portable in that sense?
So you can build fabric wherever you want to build services, right? But the migration
more about like the policies. I already know how I want this application to be secured and how I want the traffic to route, but all of a sudden I'm moving its location.
Right.
Let's take a quick example here. Let's say you're addressing the application with, rds.acme.com or something, right? As long as the address that you're putting on the envelope is not changing, Prosimo will intelligently be able to figure out where, this application needs to be routed to, right? So that's the address that you put on the envelope is important, right? If you're addressing it as rds.acme.com, policy is global across all the edges. It doesn't matter if a workload in US East is trying to access rds.acme.com, right? That policy is going to be enforced throughout the fabric. Yeah. Now, if the address you were putting on it was, let's say, a 10 dot, some sort of IP address, right? We go one step further, and that's where the transit itself is differentiated, right? We go one step further in the sense that we'll allow you to port this policy from one region to the other, take care of overlaps in that region as long as you are onboarding them in the right way. We have all those off-the-shelf constructs that allow you to navigate, the complexity of a situation like that, right? Which say I'm migrating these, applications, and they have network addresses. There might be potentially overlaps in this region, right, as they migrate, right? Instead of making this infrastructure ready, manually doing all of this configuration, we have off-the-shelf constructs that allow you to do this with speed, right, within the Prosimo fabric.
So all the policies are tied to the logical identifiers. So your physical location can change, the cloud can change. So your policies move along with the logical identifier.
So naming convention is super important here, because if I name something rds.aws.whatever, and I want to move to your point, which is I look at, day 18, I'm like, whoa, that traffic pattern makes no sense. It's causing me a ton of money. Let's move this service from RDS to Oracle on-prem. Jeff Bezos just sent me a nasty email. But from a developer's perspective, he's looking at rds.aws.whatever, and he's associating, just like static IP addresses, he's associating that service with a location in a cloud versus a service. Like I want a database, my database service, and wherever my platform team decides to put it is irrelevant because I work with
That's a great point, right? While we use the address on the envelope for routing, right, for connectivity, you could use other constructs. You don't need to enforce policy on rds.acme.com. You could enforce it on a cloud tag. Let's say, call it, hey, here are my migrated, I put a migrated tag on it. You could enforce policy on that. Behind that, it could translate to, rds.acme.com. I don't care. That policy will be enforced throughout the fabric.
Yeah, the policies themselves contain the metadata for the actual policy, and then the artifacts that attach to that policy envelope are movable,
could
right?
Be,
we show these things in action. Actually, that would make more sense.
And do you have anything in the detection of like latency or other metrics in making traffic decisions?
Absolutely. Yes, we'll show it during the demo. Yeah.
Full stack networking, full stack policy, full stack observability.